That's not a ghost. It's my 3D printer. I'm just covering it up because I don't want to get dusty. Hello, welcome back to a Fixing It episode. Well, kind of fixing it, kind of building it, but fixing it as well. I've got in front of me here a whole bunch of old Commodore 64 power supplies, and 3 of these are of the wedge variety. This one is, I've marked it as 5.25, which means that the output on this, the voltage is 5.25. I think that's under load, and that is a bit spicy for a Commodore 64, so that one won't be getting used again. But parts of it might find a second life, like the cable with the plug on the end. It hasn't got a plug on that end though, so we can get rid of that one. This one is mine. This came with my original C64C some time ago. Carsten sent me this from Germany ages ago, years ago. My first Commodore 64 was, back in the day, a C64C, and then the first Commodore 64 that I got when I started collecting again was a C64C from Carsten, and this is the power supply that came with it. Did have a German plug or a European plug on the end, and this one is okay. They're not all bad. These 3 came from Paul. We've had some problems with power supplies when Paul's tested machines that I've sent back that have been repaired, and a couple of times power supply has done bad things to those machines. For instance, one of them had a bad power plug on it, where it's supposed to have 4 pins in there, and you can see it's only got the 3. One of them broke off, and we don't even know where that ended up. It's probably inside one of the C64s that we fixed. So that's one thing. But there was a problem with outputting too much voltage, and there's a problem with these wedge power supplies, the ones that are potted in resin. There are some that are worse than others, and Commodore Lad will remind me which ones are which, but the inside of these looks like this. The AC comes in here, goes through into this transformer and this fuse here, and it gets transformed down to a lower voltage, which comes out, I think it's 9 volts AC or thereabouts. Some of it comes out here on these 2 points here and goes straight through onto the plug as 9 volts AC, which goes into the C64 to then be voltage regulated down to the required voltages that the C64 needs. These 2 points here take that 9 volts AC, and it goes through a bridge rectifier set of diodes here. There's 3 on this one, and there's 1 on this side here. There's another board over here that I've removed. So it's meant to look like that with 4 diodes at this point here. And that will change that 9 volts AC down to 9 volts DC, goes through the voltage regulator, which is attached to this point here. So that sits in there. You can just see the voltage regulator here, which is half potted in this resin. That's not a good thing for it to be. It's definitely going to cook in there, and these do fail. That's one of the problems with them. The voltage regulator fails, and it can go short and pass through that 9 volts into the C64. The biggest problem with these is the voltage regulator. The actual transformer, not such a problem. This one I'm not going to use because this was my first effort of getting a case off, and I'll go into this in a second, and I made a bit of a hash of it. So I've got these other ones here, and I've already converted this one, but in the video today I want to convert this one over to a more modern board. I haven't glued this one yet, and that's what I intend to do, but I've just taped it for now, just for convenience. And we can see inside here is a new board by Temperi that you can find on GitHub, and I'll leave a link in the description, that makes a better voltage conversion from the 9 volts AC to 5 volts DC, turns it into 5.2 volts. I'm not going to pull this up because these are quite stiff and easily broken, these wires here. But yeah, I'll go through it actually and build this and put it into this new one and then glue them up. One thing to note in here is that on this one that I tried to break off in here. There's a piece of plastic which I've now lost. This piece of plastic was glued into the resin there, and when I pulled this off, I had to break that piece of plastic off of this base. It would not come off of this resin. Later on, when I could wiggle it, it would. This one, when I took this one apart, that just popped right off. So your mileage is definitely going to vary on these, and all of these are going to be slightly different. But again, we'll go through it as I do this one. Right, so if I put these side by side, and then we'll decide what my plan of attack is. So there are different points that this is attached. It's glued with these pegs all around. I think it's actually glued along the edge as well, but not, I mean, you can still get something down in there and lever it up. So it might not be glued along the edges, but it's glued at this point here and this point here, and they are deep pegs that go into the case at this point, and they were attached to here. So this had long thick pegs coming out of this part of the base that went down into here, and once this was epoxy resin together, those are then fixed and you can't get these bits out. But we'll get to that. There's also these pegs here, these thinner ones that are attached here and here. They're glued, but they're thinner and easier to break. Then we've got along here, there are some more thinner pegs along this edge here. Those are much easier to break. So the easiest way that I found, or the way that I found I got the other one off, because this one I wrecked, was to start at this end, make sure this end is free, and then look down into here to sort out the bit this bit if you can. If it comes free of the resin, great. If not, you're going to have to find a way of cutting that so that it comes free. And then, without pulling too hard on this, so that it doesn't break these bits, I used a long chisel and poked it down in there to actually cut these bits off before they could do any damage. And that seemed to work quite well. And then once it's all away, I can just glue it back on. That will be strong enough. And I'm going to use epoxy resin to glue it. So I don't want this coming apart because it's spicy voltages are in there. So let's have a look at this one and see if I can get it open. Yeah, this one's popped straight open. So these pegs at the top have just come out. These three pegs at the top have just popped out. That's not a problem. The big problem is going to be down inside where this bit lives. Oh, I think, yeah, that L bracket is not attached. That's really good. So the only thing that's holding it is this peg here and this peg here and these two big pegs. Maybe. Oh, I've got one more peg here that's holding on this side that I probably need to. This, I mean, that's not very well attached. This is meant to be a sealed unit. I would have. Why didn't they go with glue? Sorry, screws. Would have been so much better. I'm not sure what's holding it on this side. Oh, whatever it was, it just let go. Like I said, all of these are going to be different. They'll all come apart in a different way. Yeah, this one's going to be a bit more tricky than the one I've already completed. Something here is holding on for dear life. So I did consider slicing as neatly as I could along this edge here, just to cut that post. It's going to leave an external mark though, But what I can do is weaken it with a knife. Just to score it. See the other side as well. Okay, I can just see one of the pegs down the bottom here now. I might be able to get the chisel onto. So where these pegs were, I'm going to slide the chisel in so that it goes along here nice and flat, and then just snip those off. Right, got one side off. That's cut through there quite nicely. I lost a little bit of that trim, but that's all internal, so that's not a problem. Now I can see from this side, I can see the other problem area. There we go. Oh, there's still something holding on somewhere. Something holding on this side. What is that? Okay, there's a peg here. That one is holding on here. So I can just snip that off with the chisel. Like that. And that's it. So fortunately this came away from the resin without causing problems. But I think if you get one of these with this very glued into this part, you're probably going to be in trouble. What's really good on this one is all the contacts are nice and exposed. On this one I had to change the cable because this was the one that had the broken pin in it. So I had to resolder these connections down here onto these bits here. And there was quite a lot of resin on there, and I had to just scrape it away and make sure that it was a good connection. The first thing I need to do is get rid of this board and detach it from what's going on in here. And green is, on all the ones I've seen so far, green is ground. And if I get one of the boards, yeah, so ground is that one, 5 volts that one, and then the AC is on these ones. So this should be pretty straightforward, I hope. Oh, it smells horrible. Being careful with these wires. You don't want to break these, especially where they exit the resin, because that's game over. And the only other thing that's holding this in is the 5 volt regulator, so I just need to snip that away like that. And this had a little bit of resin along there, gluing it to this bit. Different capacitor. These two were the same, and this one is a little bit different, but they're exactly the same board, and it's exactly the same capacitor rating. And all there is a couple of resistors, a tantalum and 4 diodes. Oh, and the voltage regulator. But that's now junk. So this board will sit in here once all the components are on it. Just like that. These wires will attach. And then we glue the base back on, and that's all we need to do. But before I can do that, I need to build up this board. I bought these kits off of eBay, and it comes with this bill of materials here so that I can follow this to install the components in the right places. Okay. Two of the components on this sheet are greyed out, and that's an LED and a 200 ohm resistor, and they are optional. If you might not want an LED, But I'm going to fit the LED. I'm going to fit the LED later because I want to stand it up off the board. But I'm going to fit the resistor now. They don't come with the kit. These are, you have to provide these yourself, not from the eBay seller that I bought these from. Got a big hefty diode to fit. And this one only just fits in this footprint, so I'm going to have to bend these legs straight down. Like that. Oh, we've got the this weird voltage regulator. Yeah, LM2576T. It's a 5-volt regulator, but I think he does some weird stuff with this to give a 5.2 volt output. It does explain on the GitHub, but I think if you leave out or jump one of these resistors, you can actually just make it give out 5 volts if you want to. But I don't see why you would want to do that. The first time I saw this project was Glenn from CRG did a lovely video of this project during the charity event I did last year, and he sold a VIC-20 with a good power supply with this inside, this board inside it, as part of his bundle, and raised a load of money for us. So that was really nice. But yeah, if you want to see a good video about this, someone making a bit more effort than me, then go and watch Glenn's video. I will leave a link in the description. And Glenn actually bolted this to the board. I'm not going to do that. I don't think he needs it. I'll measure this with the thermal camera just to make sure that it's not getting too hot. So if I do want to put a bolt through it, I've left it so that I can. Right, the next part I want to solder in is a bridge rectifier. These are keyed with an angle there on the corner, just to they go in the right place. Such a nice easy kit to solder together. It's very easy. Nice big chunky connections. Oh, that one's still hot. What we've got left? Got 3 capacitors and a couple of coils. So L1 is a 150 microhenry, and this one is this is a 22 microhenry. So this is L2. I didn't get that very straight, did I? That's better. It's 150 microhenry. Probably my favorite unit of measurement is a henry. Let's start with the smallest capacitors. These look like they're really good quality capacitors. Oh, I don't recognise a Chang X. When they're green and gold like this, you kind of expect them to be high quality. But I'm sure they're fine. This is a 2200 microfarad. That is C2. The lead spacing is a little bit tight, but they're fine. That's all the major components fitted. The only thing I've got to do now is put the LED in, and I'm fairly sure that the positive, the long leg, goes on the square pad, and I know that because I watched CRG Glenn's video. I'm going to leave this nice and long so that, like him, I can have it angling towards the outside of the case through the vents, and you might be able to see it. The other one I used a very dim LED, and this is a slightly brighter one, so I'm hoping it will be visible from the outside. Not important if it's not really. So all of these components just hang out in this section here, and this sits in here like this. So the only thing I need to do is attach these leads here to this. Like this. Oh, that's really hot. Green is ground, and white is 5 volts. That should be it. I'm not going to test this bit yet. What I'm going to do is plug it in, open like this, and see if it explodes. But I am going to plug it in with an RCD protector. Oh, look at this. That's no good. We need to get rid of that. So the UK plugs, here we go, here's a new one. Have this protection, this sleeve protection here. So when the earth pin is pushed into the socket in the wall, that opens up the live and neutral connections, because you can't push anything into the wall socket without that pushed in first. But what you don't want is to be able to, this to be pushed in slightly, and to be able to get your finger in there and touch the live as you're pushing it in. So these bits are insulated. It's only that bit that makes any contact. Well, this old one is, yeah, that's not current standard. So this one needs to go. I'm always curious about what's in old sockets, in old plugs. Well, the first thing it's got is a 13 amp fuse. Everything had a 13 amp fuse in, which is pretty much pointless. You might as well have a nail in there for all the protection it's going to give you. The way I prefer to do things with old mains power sockets and plugs is to make everything new. So I'm going to take this out without cutting it first, but I am going to cut the end off of this because I want to show you what I don't like doing. So this part of the cable has been crushed in this strain relief, or in this, it's not strain relief, this cable grip. It's been crushed in there for years, and that's been flexing. This one isn't too bad. I'm sure this would be fine, but my preference is to actually just chop this off right there. There's plenty of cable on this, and remake it again. Got some nice fresh cable, and got a nice fresh plug, brand new plug. And this unit is going to go to Paul, Universal Retro Boss, for his testing purposes when he tests these machines, so that we know he's got a power supply that actually works. Or we need to get rid of this fuse as well. I'll put a 3 amp fuse in this. And for all the people that, when I did my Meanwell power supply change for the Amiga 500 power supply, that said I should crimp the end of the connectors. No, this literally millions of plug sockets, plugs in this country where just stranded wires are screwed into screw terminals, and they're all fine. Well, most of them are fine if they're done properly, as long as there is strain relief. If this cable was moving, then this would be a problem, but it's not. This cable grip here will stop that movement. There we go. A perfect plug. These are just cheapo 3 amp fuses, but I'm sure it's better than the 13 amp fuse that was in there. So I'm just going to measure here to make sure the 5 volts is here, and maybe the 9 volts as well. And then I'll try it at the plug. I can see the LED is lit down the side there. You can see it through the vents. That's nice, actually. .24 volts there. And AC. Not sure if I'm going to get good connection on these. No, I'm going to do it with the other end. It should be these top 2 pins here. 10.19 volts. Let's check the 5 volt as well. 5.24. Perfect. Happy with that. All right, so now we know what the voltage is inside here. Let's see what it is like with a Commodore 64 attached. Here's my lovely test board. Gets put through all sorts of nasty stuff. It's got a SID attached to it, so it's just as much voltage as you would expect to come through one of these. Right, that's live. And the C64 you can't see, but that has just lit up. I have attached a bolt to the voltage regulator, and we can see on the thermal camera that this side of the board gets quite warm, and it's only 29 degrees around that voltage regulator, and there's a bridge rectifier underneath there as well, so there is a bit of heat, but there's no more heat than there is inside this. If I'm pointing down here, you can see there's some glowy bits here. That's the bridge rectifier inside the C64. That's exactly the same deal as what's happening up here. Right, so voltages inside the C64. I'm measuring across a logic chip here. 5.02, perfect voltage. AC on the edge connector is 9.12. Yeah, it doesn't get much better than that. That's a really nice supply of voltage. Right, that's now a complete power supply, and all I need to do is reattach this. Now, Glenn did put some screws in his, which that makes me nervous, because he drilled into the epoxy resin and drilled out some of these holes here and screwed through the base so that he could service it if he needed to. But I'm just going to glue it. This is going to be a one and done deal. I don't ever want to come back in here. I'm happy to glue it closed, but I'm going to epoxy resin glue it, and hopefully that will be good enough. I'm sure someone will complain at me in the comments. Another use for blue tape. That's that tube done. Sticky. Oh, I've made a mess. Right, I'm going to put this somewhere with a big heavy weight on it and leave it overnight. Right, that one's done. It wasn't a very complicated thing, but it was nice, a pleasant thing to build. And I'm hoping that that's 2 C64 power supplies that I can rely on now. It's difficult. I've already got my amazing C64 power supply that was built by Adam Commodore lad, and that's my main testing one. But it's nice to have other ones if I need to have other machines fired up at the same time. If I'm comparing signals, I need to be able to rely on 2 power supplies. And now I've also got one to give to Paul, Universal Retro Boss, so he can test his C64s and make sure they're really broken before he gives them to me to repair. Anyway, I hope you enjoyed that. I'll see you in the next one. Goodbye. Buttons.